This is the 2.3 part 1 video. We're going to be looking at applications of linear equations. So we have a couple steps to look over here at the top, just to kind of help guide us when we're working out an application problem or a word problem involving linear equations. Step 1, read the problem carefully and identify known quantities. Step 2, assign a variable to represent the unknown quantity. If there's more than one unknown, find a way to write the second unknown in terms of the first unknown. So you want to figure out how they're related and write an equation that relates one of the variables to the other one so that you really only have one unknown that you're dealing with. Step 3, write an equation using the variable expressions. Step 4, solve the equation. And then step 5, state the answer to the problem and make sure that it seems reasonable, and then check the answer in the words of the original problem. So that last step is just kind of stating your answer and making sure that your answer actually makes sense. All right, number 1, there are two cell phone companies that offer different packages. Company A charges a monthly service fee of $34 plus 5 cents per minute talk time. Company B charges a monthly service fee of $40 plus 4 cents per minute talk time. Write a linear equation that models the packages offered by both companies. So first of all, before we write the equation, we need to make sure that we're following these steps. So we read the problem. Now we want to assign a variable to represent the unknown quantity. So usually that's just what they're asking for. It says, it doesn't say up there actually. It's going to say at the very bottom what they're actually asking for. How many minutes of talk time? Right? And so that's what we don't know, is how many minutes of talk time that the person is going to use. So we'll let T represent the talk time. And then I'm going to go ahead and write my units there. That'll be minutes. Okay, so write a linear equation that models the packages offered by both companies. Okay, so Company A, they charge monthly service fee of $34 plus they charge another 5 cents, so 0.05 per minute of talk time. So that's going to be times T. So $34 plus 5 cents per minute. Company B charges $40 plus 4 cents per minute of talk time. So those are our two equations. If the average number of minutes used each month is 1,160, which company offers the better plan? So if you're somebody who uses this many minutes on average, you're trying to determine which company you should go with, which one is going to come out with a better deal. So to do this one, we're just going to actually plug in that 1,160 into each equation and see which one gives us the better deal. So that's going to be, Company A is going to be 34 plus 0.05 times 1160. Then Company B is going to be 40 plus 0.04 times 1160, 1160. Okay, now we can type that into our calculator. Okay, so Company A is going to be $92. Okay, do the same thing for Company B. 4 cents and that initial $40. So Company B comes out to $86.40. So not a huge difference. But if you think about that adding up over months and years, you would definitely want to go with company company B. Company B is going to give you the better deal if you are using about that many minutes. Okay, going with the cheaper right there. All right, part C, how many minutes of talk time would yield equal monthly statements from both companies? Okay, so we're looking for where the cost is going to be equal. Okay, so these are both equations to calculate the cost. So if I want to figure out when they would be equal, how about if I just set them equal to each other? Okay, so going back to those original equations up at the top, we've got 34 plus 0.05t equals 40 plus 0.04t. Okay, now we can solve solve that equation. So I'm going to subtract the 0.04 on both sides, and that gives me 0.01t. Subtract the 34, so it equals 6. Now you just have to divide by 0.01. So we can see at about 600 minutes, or actually exactly 600 minutes, both companies would charge the same exact amount. All right, number 2. Ben originally filled out 8 more applications than Henry. Then each boy filled out 3 additional applications, bringing the total to 28. How many applications did each boy originally fill out? So we're looking for how many applications they originally filled out. So I'm going to let my variables be B for number of applications for Ben filled out. Originally. And I'm going to let H be the same thing for Henry. Okay, so originally Ben filled out 8 more applications than Henry. So we can relate the B and the H. So just like it was saying in step 2 on the previous page, if you have 2 variables, which we do here, you want to find a way to relate them to each other. So this is going to relate them. Because Ben originally filled out 8 more than Henry, so you can say B equals H plus 8. Ben did Henry's amount plus 8 more. Then each boy filled out an additional 3, and the total was 28. So you could say Ben plus 3 plus Henry plus 3, so their original amount plus they each filled out 3 more, and the total came out to 28. All right, so this is B plus H plus 6 equals 28. Now let's use this right here to make our equation only have one variable. Because B equals H plus 8, I can replace this B with H plus 8. So I'll do H plus 8 plus H plus 6 equals 28. Okay, now I only have H's, so I can do 2H, adding those 2 together, so plus 14 equals 28. Subtract the 14 on both sides. So 2H equals 14, and then H equals 7 when you divide by 2. So it looks like, remember what the H stood for, the original number that Henry filled out. So he originally filled out 7. Now to figure out how many applications Ben filled out, we can use this equation, the b equals h plus 8. So just 7 plus 8, which is going to give us 15. Okay, so I'm going to go ahead and write my answer over here where I have some space. So for Henry, that's going to be 7. Applications. And for Ben, 15. All right, number 3. A game room has a perimeter of 70 feet. The length is 5 more than twice the width. How many square feet of new carpeting should be ordered? Okay, so we've got a game room and the perimeter is 70 feet. So remember, to calculate perimeter, you're adding all 4 sides. I'm going to draw a picture. Game room. Here's our length and here's our width. And so the perimeter is going to be 2L plus 2W. So just adding all 4 sides. And it says that it's 70, so equals 70. The length is 5 more. So the length is 5 more than twice the width. So you can do 2W plus 5, twice the width, and then 5 more than that, so 2W plus 5. So now, we've got our variables. Our variables are length and width, W obviously being for width, and L obviously being for length. Since we have 2 variables, luckily they gave us some information to relate them, and that is this L equals 2W plus 5. So in my perimeter equation, I will replace the L with the way it's related to W, which is 2W plus 5. So I'm going to do 2 times, parentheses, 2W plus 5 plus 2W equals 70. So the reason we do that is so now we only have 1 variable in our equation and we are able to solve. So we'll solve for W, distribute the 2. Combine like terms. Subtract that 10 over. Divide by 6. Okay, so the width is 10. In the units, if you look back at the problem, are feet. So now we need to get the length, and remember the length is 2W plus 5. So that's going to be 2 times 10 plus 5, 25. 25 feet for the length. But let's see what they were asking for. How many square feet of new carpeting should be ordered? So when you say square feet, you're talking about area. We're talking about area. So to get the area of the carpet, area is length times width. So we need to multiply 10 times 25. Well, I wrote those backwards, but it's okay. Maybe not. Length times width. So 25 times 10, which is going to be 250. And then the units on that, since you just multiplied 2 numbers that have units of feet, your units are going to be feet times feet, which is feet squared. Okay, so they need to order 250 square feet of carpet. All right, number 4, our last problem for today. Trissa drove to her grandmother's house for a weekend visit. She averaged 40 miles per hour driving there on Friday. As she returned home on Sunday, traffic was lighter, so she was able to drive to average 48 miles per hour, and her drive time was 1 hour less. What is the distance between Trissa and her grandmother's house? Okay, so one thing we need to know here is that distance equals the rate times the time. That's one thing you need to know here. Distance equals rate times time. So on the way there, I just need to write out this information because there's a lot of information in this problem. So on the way there, I'll just say there, she averaged 40 miles per hour. So that's her rate. So I'm going to put R equals 40 mph. She returned home, so coming back, I could say. Just organizing my information. Traffic was lighter, so she was able to average 48 miles per hour. So R, the rate, equals 48 miles per hour. And her drive time was 1 hour less. Okay, so we don't know on the way there how much time she took, but we know on the way back, if she took T hours on the way there, then she took T minus 1 hours on the way back because she took 1 hour less. So I'm going to say the time equals T here, and I'm going to say the time here would equal T minus 1. Okay, so now that I have my variables, we want to figure out what the distance between Trissa and her grandmother's house is. Well, one thing I can tell you is that on the way there and on the way back, the distance did not change unless you took a different route, which we're assuming she did not. So if she took the same route on the way there and on the way back, the distance did not change. So with this formula, D equals RT, the two distances are going to be equal. So the distance on the way there, that's going to be 40, your rate, times your time. Your distance on the way back is going to be your rate, 48, times your time, which is T minus 1. And we know that those two have to be equal, so we can just say D1 equals D2. So 40T equals 48 T minus 1, and we can solve that equation. So the only thing I knew here was that the distances were equal, so I set them equal to each other, the two distances, and now I can solve for T. So 40T equals 48T minus 48. I am going to subtract that 48, so negative 8T equals negative 48. Divide by negative 8, so T equals 6. Now, we're looking for the distance between Trissa and her grandmother's home, so we're going to plug that T back into either one of these equations to figure out how far it actually is. So D equals 40 times 6. If I use the first equation, which is 240, and you should see that if you plug that into the second equation, you'll get the same thing. Doing 6 minus 1 is 5, and 5 times 48. So 5 times 48, again 240. And the units here are miles. Because the rate was in miles per hour, the distance is in miles. All right, perfect. That's it for today. We'll finish these notes in part 2.